Hello everyone, welcome to Linked Frequency. I'm Vaibhav Sugandhi, and in this particular tutorial I'm going to talk about how to integrate two sensors with Arduino development board using Tinkercad platform. In previous tutorials we discussed instructions for Arduino development board and IDE, and also we discovered how to use Tinkercad platform for simulating and conducting our experiments. Now we are going to talk about how to integrate two different sensors with Arduino development board and create a code for that. Without further delay, let's get started. Alright, we are in front of screen now, and I'm going to show you how exactly we can interface two different sensors with Arduino development board. In this tutorial I'm going to use basic sensors. Why? Because we are not focusing on a circuit more, we are more focusing on the protocol or the procedure, how to organize your entire code so that you can integrate multiple sensors or maybe multiple actuator, or for that matter you can build an embedded system, which we are going to cover in a future tutorial. But right now I'm going to focus more on how to organize your code for creating combination of couple of sensors or actuator circuit. Okay, so we are in Tinkercad platform. I believe you watched our previous tutorial all about how to integrate sensor, actuator and everything. Now I'm going to click on create a new circuit so that I can start with integrating a circuit first, and then I'm going to write an Arduino code. Okay, so first of all here I'm going to change the name of this project as maybe a two sensor integration, because that is more appropriate. Two sensors integration. So two sensor integration with Arduino, more detailed one. So thereafter I need not hit that control yes, because it is auto saved, it is online hosted. So make sure that you have active internet connection before using this platform. Of course you cannot log in without internet, by the way. So thereafter what we need to do is we need to change this component section to all sections so that you can see all the sensor, actuator or the components available in this virtual platform. So I'm going to scroll down, and we have an input section here where we have push button and potentiometer. I'm preferring to go with push button and potentiometer because one is analog sensor, another one is digital sensor, and I can show you how to combine your code to develop one system code, that is a firmware in at the end. Okay, so I'm not going to use little bit complex sensors here because it is going to consume a lot of time and it becomes really difficult for beginners to understand, and this course is more focused for absolute beginners. That's why I name called Arduino course for absolute beginners. That's why I'm going to use a basic sensor. Before using the sensor I need to bring a breadboard so that we can create a circuit on that. Breadboard. So I'm going to use a small size breadboard because again this is not a big circuit to consider for a big breadboard and all those things. So I'm going to bring this push button and place it somewhere here. Make sure that you place this push button in between this slot available here, A, B, C, D, E. After that there is a slot and then F starts. So make sure that you place your push button there only. Otherwise if you place it like this, what happens, you are shorting a terminal 1B with a terminal 1A, which means you are creating a short circuit in the entire push button. Whether you press it or don't press it, it is always short. So make sure that you place it in the slot so that you can utilize the real function of that particular push button. Thereafter we have a potentiometer, which I'm going to place a little bit far so that we can make a circuit a little bit good. So thereafter we need a resistor so that we can pull up the push button so that it holds the potential to VCC when it is not pressed. So I'm going to connect it to somewhere here, because we have a plus indicator here in a small breadboard. That doesn't mean there is a positive potential available by default. We have to connect a VCC to that particular trail so that it is get connected by default. So it is indicated with a plus sign and a red color, so that's why I'm using that as a plus. There is no hard and fast rule. You can even swap the voltages at this point and you can call them as a VCC as per your requirement. So right now I'm going to change the resistance value to maybe a 1 kilo ohm is sufficient. When we are using a pull-up resistor, 1 kilo ohm is very good, but still I just prefer to go for 4.7k. that's my choice. There is nothing special in that. You can go from anywhere between 1 kilo ohm to 10 kilo ohm. There is no problem. There is a proper calculation for that, however, but this is a beginner's video, so I just don't want to go with a lot of mathematical calculations and all. So this is a pull-up resistor, and then we have potentiometer and a push button. Very important Arduino development board, which we forgot to bring. So let me bring Arduino Uno R3, which is Arduino development board for our entire experiment here. So thereafter, which we need to do is, the most important thing that we need to do is connecting a VCC and ground. I'm going to use a plus 5 volt and a ground from this particular section. So I'll just take some drag here and connect it here. Do remember, I'm connecting it extra to the bottom side trail as well. Again, this is not connected with the top side trail, so personally I need to do it by doing like this. So do remember, they are not internally connected, though they look similar, the symbolized with the plus sign and a red color, they are not internally connected. You have to do it by yourself, and my favorite, I'm changing the color of these connectors because I want to do it all the time. So thereafter we have potentiometer here. So one side of the potentiometer, which is a terminal B of the potentiometer, is connected to VCC as per my knowledge. I mean, it's your choice. You can connect a terminal 2 or terminal 1, whichever you feel comfortable, but terminal 2 is a much good one, because when we rotate this potentiometer, if it is rotated in a clockwise direction, the value should increase at the wiper side, right? So that's why we are connecting it to VCC when we have a terminal 2, and terminal 1, obviously it goes to ground potential, which I'm going to do now. So ground connection I'm going to do with another trail available here, which is just like this, and I just try to make sure that all things are looking professional as well, not just working or maybe a functional, right? So I'll keep the ground trail only available at the bottom side, because I don't need ground trail on the top side. But if you wish to have it, you can just drag and drop one wire here. That is quite simple, but okay, we have drawn it already, so let me keep it as it is. So thereafter I'll connect terminal 1 of a potentiometer to so terminal 1 of a potentiometer to ground potential, so that our potentiometer is having a not two references, both terminal 1 and terminal 2 are connected to proper connection like ground and VCC. Now we have a wiper here. In early case, in previous tutorial, I have used single resistor with a wiper output, which is not really necessary, but if you want, you can use it, but it is not really necessary at this point of time. There is a reason for that, by the way, technical reason for that. However, I will not go deep into that particular thing, which is not a matter of concern at this point of time, so I'm not going to use it at this point of time. So we need to connect this particular wiper output to one of the pin in Arduino Uno development board, and then we have one more pin here which is need to be connected to one of the pin in Arduino development board, which I'm going to discuss right now. However, the push button one end is connected to resistor, and the resistor is pulled up to VCC, and another end, this is one point, and another point of this push button, which is a terminal 2, either A or B, should be connected to ground potential if you want to create active low configuration. Do remember, when we are pressing this particular push button, we want to generate a low signal for our microcontroller or maybe Arduino Uno development board for that matter. On that time, you have to connect push button in this fashion. If you want to create an active high configuration, there is another circuit which is little bit different from what we have built so far, which I'm not going to talk right now because that is not a matter of concern either. So I'm not going to worry about much about those configurations and all, but right now the most important thing that we need to worry about is where to connect, which GPIO to use for which sensor. This is analog sensor and this is a digital sensor, and in previous tutorial I literally explained as much as possible in detailed way to bring point in front of you that which pin is responsible for what kind of sensor. So push button is a digital sensor because it generates either 1 or 0, or you can say logic high and logic low. For that we need a digital GPIO. We don't need analog GPIO for that. Even you can use analog GPIO as a digital GPIO, which is possible, but we don't need analog GPIO for that, because it is just a digital signal that is generated from mechanical movement of the push button when user presses that. Wherein this wiper or maybe a potentiometer is an analog sensor. It cannot be used as a digital sensor in proper context, but if you go technically and if you do some jugaad, then of course you can use it as a digital sensor. But no, right now we are going with a theoretical data and also a practically possible data, which is all about digital, not digital, analog sensor. So it is an analog sensor. Why? Because it is producing an output in the range of 0 to 1023 for that matter with the Arduino development board. But in general case, if you talk in terms of electronics, it is generating a voltage potential difference between 0 to 5 volt or 0 to VCC, whichever we are connecting another terminal. Right now a red color wire indicates a 5 volt connection. Why? Because we used a 5 volt from Arduino Uno development board. So this potentiometer is generating output voltage from 0 to 5 volt, because of which I am really using this as an analog sensor. So do remember, we have to connect an analog pin, or we have to use analog GPIO for this particular sensor. So I'm going to connect it to maybe I think I feel we can go with A0 this time. So I'll just drag it and connect it somewhere here. Let me see whether it is correct or no, it's not correct. So let me select it and make it somewhere here and bring it to this place. Thereafter we need to connect it directly to the wiper. Okay, so I'm going to change a color to, say for example, a blue one, because wiper looks like a blue color. So it's just a choice of color, but color doesn't change the electrical parameter, by the way. So done. So this is how the connection is need to be done for the potentiometer. Thereafter we have a push button. So now this push button resistor terminal, or maybe one terminal of the resistor is connected to VCC and another terminal is connected to one terminal of push button, which we are going to connect to one of a GPIO. So I just want to go here and connect it to maybe a GPIO 6, I guess. Just a random guess, there is no specific reason for that. So I'm just going to change the color to yellow, because resistor lower band looks yellow. So crazy reason, but yeah, there is no specific reason for that. Okay, so this is how we need to connect our Arduino Uno development board with these two sensors that we are using. One is push button, another one is analog sensor, which is all about potentiometer. Okay, now we need to work on creating a code for this, which is again one of wonderful moment for me. So I'm going to use Arduino IDE for that matter right now. So I'm just going to use this Arduino IDE for developing a code for that. Let me clean up all these comments which we don't want right now, and I'm going to use a preprocessor directive. So I'm going to create a little space for the preprocessor directives. Make sure that you have saved this particular code in your specific directory, wherever we are talking since the beginning of this entire course, at least from place where we started using Arduino IDE. So make sure that you maintain your files properly. Now I'm going to use a preprocessor directive like #define pot, which is a potentiometer, short form of pot, which is connected to A0 pin. I hope so. Let me check once again. So yeah, it's connected to A0 pin, analog 0 pin of the Arduino development board. And #define button, we have a button, right? So button, which is connected to a D6 pin, which is generally known as a 6th GPIO. So thereafter what we need to do is we need to configure those two pins as input, because both are sensors, right? So hope you remember those basics which we discussed in previous tutorial. So pot not necessarily need to be configured as input. Explicitly we need not to write this particular instruction for analog GPIOs, or maybe you can say analog pins of Arduino development board. But right now I believe it is good to sorry, I made a mistake while talking. It is good to write by explicit so that you can remember how to use these instructions. Okay, so we have a button it's not a bottom, it's a button. So again, I'm going to make it as input. It is mandatory. This one is mandatory. Why? Because it is a digital pin, and by default digital pin cannot be not assumed as input, neither output. So you have to mention explicitly whether you want to use it as input or output. So we are done with this. Along with this, I would like to go with serial monitor, because we need to monitor what's coming from these sensors or how our microcontroller is processing that data. So so serial dot begin, which is instruction which I use for starting a UART communication with Arduino development board, and with a 9600 baud rate. And there is a small welcome message for us, serial dot println. I hope you remember what is the reason we are writing a ln at the end of the print statement, because to bring the cursor to new line. Okay, so welcome to two sensors integration with Arduino. Quite a big sentence, but that's okay, looks crazy. Okay, thereafter we have a loop section here. I'm going to hit that Control S again and again. This is my muscle memory, however. So here what we need to do is we need to declare a variable to store the data that is received from, or maybe read from, the GPIO. Okay, we need to create a two variable here. One is digital variable, or you can say bool kind of a data type. Why? Because it has only two state, push button, which has only high state or maybe a low state. I mean, that particular GPIO which is connected to push button is only capable of having a two state. One is high and low. To store this two state, we need only one bit, isn't it? Right? For that reason, we are going to use bool data type, which is a special data type which is available in Arduino IDE alone, I believe, because in normal C programming we cannot see a bool data type in general, but I really don't know if it is available. But here we are going to use a variable name as button data. Okay, we can write our name also here. It's a user defined name here, so there is no restriction on that, but using a proper name is very good when we are starting with a programming. Okay, initially I'll keep this as a 0. Why? Because no, it should be high, right? Because it is pulled up. We can keep it as a 0 because it is pulled up externally, so I think we can read it again and we can configure it. So let me bring a little bit above. I mean, I'll just use a little bit of space here. Okay, so after this is a data type, or this is a variable for data reading from push button. I mean, the GPIO reading from data coming from a push button. What about analog pin? For analog pin, we need to go with integer data type, so int, or maybe we can go with a float, but a bit complicated one, so let me go with int one. So pot data is a variable which again starts with a 0. Initially I am just declaring these variables. I'm not using them directly, but in most of the cases what happens when we are writing a code, people use these variables after declaring immediately. That is a wonderful way of doing it, but right now for your understanding I'm just trying to do it in a different way. Okay, after declaring the variable, we need to use those variables again. So how to use them? Use that variable to store the data that is received from that particular GPIO. And how to read a GPIO? If it is a digital read, I mean, if you are reading a digital data from the GPIO from a digital pin, then you have to go with the digital read, and the pin is button, right? Because button is connected to a digital pin, and which pin and everything which is already declared on the above. So after that, we need to read the data from an analog pin, which is again stored in a variable called pot data. And how to read analog data? Analog read. Okay, name only indicates. So, okay, why I'm doing so much of mistake. So we have a pot as a preprocessor directive here, which will replaced by A0 in a later stage while compiling. So I'll hit a Control yes and also Control T, which will arrange our code in a proper manner, indentation basically, right? So we read the data and placed it into a variable. Now I want to see that data on a serial monitor. How can I do that? I can use a very simple instruction called serial.print. I'll just use a serial.print right now. There is a reason for that. I'll show you, not using a println, because I want to print everything in a single sentence. So when we are using a println, then after printing that much of data, it will come to a new line, which I don't want at this point of time. So why? Because a pot, sorry, why it is going so wrong. pot data is equal to, or maybe I'll use a colon for this particular application, and thereafter again I'll come back and I'll write a serial.print, not println. I will put a pot data here, I mean the variable pot data. Okay, so it will print the pot data exactly after pot data colon. Okay, after printing that particular string, it will print the value whatever is read from that particular analog pin, and thereafter what we are going to do is we are going to write one more part of that. We are not using again println here, do remember. Why? Because I just want to go with single line explanation. So button state, I just want to use capital here, button state, which is again a very important one. And thereafter when we are printing the last information, which is button state or maybe a button data, then I'm going to use print ln. What happens after this last data, whatever is coming from a push button or maybe a GPIO, whichever connected to push button, after printing that value or maybe printing that number, the cursor will go to the new line. That is what we want. That's why we are using println at the end. Thereafter, if you really want to add a little bit of dash 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 to signifies between one line to another line, which is not so necessary, but if you want, then again you can do it by yourself here. Otherwise you can just go with a delay, adding a small delay here so that you can visualize the output. I go with a 1 second delay usually, so I'll just keep it as a 1 second delay, and I'll remove all these unnecessary enters I used. Okay, this is a very simple and very easy code that you can write for yourself to integrate two sensors with Arduino development board. I believe it is going to be a working one, so I'll just copy a code from here. I'm not compiling, by the way. If you want you can compile it, but yeah, I just want to give a try. Let me compile it, let me see if whether it works. I mean, I hope there is no error, so let me see if we have any error. I believe there is no error, I think so. Yeah, it is taking too much of time. Great, amazing. We can see that there is no error in the entire code. That's amazing. So I'll just copy it and I'll go back to Tinkercad platform, and here I'm going to hit that code section, change it to block to text alone, hit that continue, and delete all the code available existed and on this platform. So thereafter I'm going to paste my code and cross verify once again whether we connected a A0 pin to Viper. Yes, and button is a GPIO 6. That's amazing. Both are configured as input and serial monitor is started and everything is here. Great. I'm not going to hit that Control S. My hand is going there, but yeah, I'm not going to do that because it is auto saved because it is run by internet. Okay, thereafter I'm going to open the serial monitor here and just hit on that start simulation. Okay, just waiting for a second. Wonderful, you can see that the data is in front of us. Can you see this one? Welcome to two sensors integration with Arduino development board, and you can see that pot data is 0 and button state is 1. Now what I'm going to do is I'm going to change the potentiometer Viper position. Wonderful, can you see that one? When I change the Viper position, the value of that pot data is getting printed exactly after that pot data string without disturbing a button state, because I have used a tab here actually. Can you see this one? \T indicates a tab actually. Okay, so when we are using a tab, it will not disturb the next coming string, whatever it is printing. Okay, now push button is showing it is having one state, which is digital bit 1, which is a high logic. Now let me press this button. Wonderful, we can see that there is a low signal generated at the push button output side, which is a terminal, and it is connected to GPIO, and GPIO is able to sense that particular press. So when we release it again, it will come back to state 1. Okay, that is the reason why we are using this pull-up resistor for such avoiding forbidden state, or you can say avoiding unexpected change in the value with respect to that particular GPIO. We are using this pull-up resistor. Okay, for more detail, if you want, you can go through certain articles available in the internet. Okay, so it is so called pull-up resistors and pull-down resistors. So now we will change a little bit. I think I'll just experiment whether we can get 1023. Yes, great, we can get 1023 and back to 0. Wonderful. So this is how we need to integrate, sensors, a couple of sensors with Arduino development board. The major reason why I opted for push button and potentiometer is all about, one is analog sensor, another one is digital sensor. So I wanted to show you how to configure and how to use two different sensors with one development board. Do remember, understand the way in which I have written this code, not just the code or maybe the circuit. Okay, try to understand why I have written here, and I have not added a delay after every instruction, or maybe after reading a data from push button I am not adding any delay. I am reading both of them at a time. However, the microcontroller inside Arduino development board, which is ATmega 328P, is going to execute it in a sequential manner, which means it will execute these first instruction, which is reading a data from push button, or maybe a GPI which is connected to push button, and then it is going to read a data from analog pin. Okay, so it will do that sequential execution. You need not to worry about it, and you need not to add any delay in between. Then only you are able to read the entire data in a very fraction of second, you can say, in microsecond, I would like to say. But thereafter, when you are printing it on serial monitor, you have to print it in a little bit careful way, because I explained you why I'm not using a println. Okay, thereafter I'm using a delay. So make sure that you understand the protocol rather than just understanding the code or maybe a circuit. Wonderful. I believe you understood the entire process here and understood the way in which we create a code for integrating a couple of sensors with Arduino development board. I hope you enjoyed too, and you consider subscribing to our channel Linked Frequency. Tune yourself to make a difference.